complete our equipment part. So talking about surface control system. Here we have our main components for our control system. BOP control system for surface installation normally supply hydraulic fluid in a closed loop circuit as a actuating mechanism. So volume of hydraulic fluid taken to make closing function, okay, to make closing function, displays the fluid in the opening chamber again to the reservoir tank. Then if we need to make opening function, so we're gonna pump in the opening chamber, so the closed volume or the closed fluid used for closing function back again to the reservoir tank, okay? So it's called closed loop circuit. So volume used to open, okay, allow displacement for volume used to close, and volume used to close allow displacement for volume used to open, and vice versa. Here is a storage tank or storage reservoir. Okay, this is an equipment for supplying ample fluid to the pumping unit. We taking the fluid from the reservoir tank and start to pump it by easier electric pump and or air pump or punctuating pump. We have pumping system for pressurizing the control fluid. We have electric pump or air pump, pneumatic pump. And here is the accumulator bottles. Here we having accumulator bottles to start, okay, store fluids in it. So here's this accumulator bottle for storing pressurized fluid to can make the function if the power has been filled to the unit or to the system. In case of any failure, we're gonna use the accumulator bottles to make function. And let's talk about the bottle itself. The bottle is pre-charged with nitrogen. Why nitrogen? Because nitrogen is an inert gas, so it's come to the field with pre-charged pressure 1000 psi. Then started to pressure it till with oil, okay, till its pressure reaching 3000 psi, the pressure of the accumulator. Then after doing the function, after doing drawdown test or doing our function, so drawdown test here refers to close your annular, close 4 rams, okay, minimum 4 rams, and open HCR. So the pressure at the end of these operations need to be at least 1200 psi. So this pressure is called minimum operating pressure, okay, and we're gonna talk in detail about that. Here is the hydraulic manifold for regulating the control pressure to the rams, and also annular regulating to regulate the pressure to the annular POP itself. Why regulation? Because the accumulator pressure is about 3000 psi. So we need to regulate this pressure to decrease that. Okay. For example, rams needs about 1500 psi, and annular needs from 600 to 1500 psi. So we need to regulate this pressure. So here we have regulators, okay? After that, we have here remote control panel. This remote control panel to allow you to make function from remote area or remote places is to push your hand on the master valve, then open or close the function as you want. If you look here, this is the COMI unit schematic, basic surface stack, okay? Here, if you look here from beginning, we have here air pumps, we have here electric pump, and here is the storage tank. And at the beginning, we have here rig air pump, and the rig air pump is about from 120 to 125 psi, and it is okay till 75 psi, okay, to run the whole system. So here, after rig air, it's okay, it is turned to air pump and electric pump. These two pumps take fluids from the reservoir tank and start pumping or pressuring these fluids till the accumulator pressure reaches 3000 psi. Okay, so here the electric pump, once the pressure in the bottles or in the accumulator system reaches 90% of its value, so if it's reached to 2,700, now electric pump starts to charge pressure again. And here, air pump, it is below by 5%. So if the pressure reduced to the limit 85%, okay, so it's about 2,550 psi. So now it's time to air pump to start pumping again to pressurize the fluid into the accumulator bottles, okay? Here we need to have something called auto hydroelectric pressure switch, this one, okay? And here hydro pneumatic pressure switch. For air or for electric pump, if the pressure started to increase above 3,000, so we need switch to be close this increasing. So once the pressure starts to increase above 3,000, this hydroelectric pressure switch has been failed. Also for pneumatic, the same thing, okay? And here we have a panel selector valve to can take or make your operation from the accumulator common unit itself or from control panel, remote control panel. And here is the regulator valves, okay? We have here the relief or bypass valve, this one bypass valve, to allow your full accumulator pressure 3,000 psi to be applied on the shear ram to cut the drill string. And we have here shuttle valve to can isolate your pumping system from bottles and your bottles from pumping system. Okay. Okay. And here we have air junction box. Okay. All the lines of the regulator here connected, and there is transmitter to give signals to the remote control panel to can make the function. So if you look here, we have the bottles and reservoir tank. So after taking reservoir tank, pumps start to pumping. So fluids are stored in the bottles here for any case of failure. Then to make your function for open or close, annular, upper or blind or lower rams. Here is the POP unit and gauges, closing unit and closing lines, close open, and the bottles, regulator, BOP stack, regulator, here there the 3 position 4-way valves, and we're gonna talk in details about it. For annular, 3 position 4-way valve, and here the 4-way 3 position valve itself. For opening or closing, we need here 3 position, open, close, or block, okay? And this is the reservoir tank to take fluids from it. So in case we need to make close function, so after pushing the master valve, then close, for example, for annular, the fluids have been taken here into the closed area, closed chamber, and start to pumping to make seal around the pipe, okay? And once we need to open here, we start pumping in the red color or red line here. So the fluid in the closing chamber have been displaced to the reservoir tank cane. Okay, it's closed circuit or closed reed. Volume to be taken from reservoir to close, it is the same volume here from opening chamber back again to the reservoir tank. Okay, so how to know that the function has already done? Once you pushing master valve and you need to open or close, okay? Once the light has been changed from red to green, for example, so you need to open, okay? So now you need to open. Once the color is changed, that gives you indication that the 4-way 3 position makes the function, okay? But we need to await for pressure changes. If the accumulator stays the same and the annular stays the same, so in this case, there is blockage, okay? If the accumulator decreased and annular decreased and still decreasing, this gives you indication there is leaking. But what will happen if you need to make the function, okay? So your pressure stay constant and the light didn't change. This gave you indication that here the 3 position 4-way valve has been stuck, okay? Okay. Here there is gauges, and there is cover also always on the blind ram or shear ram. Not anyone use that by mistake. And there is sensors also. If anyone try to open this cover, the sensor on the rake side has been alarmed. So we know that someone tried to use the shear ram or blind ram. Here is the electric pump, pneumatic, and here is the accumulator bottles. The pre-charge for the accumulator bottles is 1000 psi. After charging it to the full accumulator pressure 3000 psi with the oil, hydraulic oil, okay? So the pressure, it will be 3000 psi. Now the usable volume of oil after conducting the drawdown test, it will be about 5 gallons. So we can know the volume required to close the functions or for closing function to can determine how many bottles we need in our rig side. So after charging the full accumulator pressure, okay, we need to isolate the pumping system from here. From the COM unit itself, we have here shuttle valve, okay? So we need to isolate our pumping units and start using only the accumulator bottles to check its efficiency. So we need to make something called the row down test. We need to close annular, close minimum for rams and open HCR. So the minimum pressure after drawdown test will be 1200 psi. It's called minimum operating pressure. Once it's below 1200, so it's called fail test. Once it is above, so it's okay. So what happens if the pressure is below 1200? We need to awaiting for 15 minutes till pressure build up. If no build up, we need to waiting also another 15 minutes. Okay. So if it is build up in this area, it's okay. If no build up, so we need to check for the error. Okay. Okay. Also, if we need to check the efficiency of the pump or the capacity of the pump here, we need to isolate the bottles, okay, from this valve, from shuttle valve, okay, and we need to check the capacity of the pump. So we need to close the annular, open HCR, and this function need to be done within 2 minutes. This is for checking for bottles capacity and for pumping unit capacity. Okay, after that, we're gonna talk about the remote control panel. Why remote control panel? It is used to make your function from a remote area. It is in the it is in the tool pusher room, okay, and one at the driller one. So to make the function, you need first to apply the push valve or master valve, then try to open or close your ram. Here, minimum one remote panel, graphical representation of BOP stack like you see. Here, annular, then shear brine. Here, bottom ram. Display position of control valves, and here regulators, okay? And the reading of the regulated pressure, okay? You could read the accumulator pressure, the manifold regulated pressure, the annular regulated pressure, and the rig air pressure, okay? Audible, visible alarms for low accumulator pressure, low rig air pressure, low hydraulic, reservoir level, and standby power. Two-handed operation, as you need to push by one hand, then make your function by the other hand. Here is the remote control from below. It's connected from here, from this section. Okay, if you look back to the accumulator schematic here, this one, okay, it's called air junction box, connected to the remote control panel to can take the reading of all of regulated pressure, this one, to give you reading of regulated pressure of accumulator pressure, okay, and to make your function by selecting from here. If back again here, we have here something called selector. This one, panel selector valve. If you turn it to panel, so you can control from panel or from the area itself. If you back again to the direction of the common unit itself, so you can only take the function from common unit, not from control panel. Okay. So here we're going to talk about choke manifold. We have downstream and upstream. Give a safety and flexibility when circulating out a kick. We have two chokes. One is backup for the other. Okay. It is a stack or a range of valves, arrangement of valves. You need to open or close to control the situation of circulating out a kick. So what is the choke, guys? A choke like this here. We need to control the back pressure during circulating out a kick. So the objective of the choke to control the back pressure by open or close. So once here, we gonna lower down this needle valve. Okay, so the pressure will be packed or will apply back pressure. Once we open by moving it upward, okay, so the back pressure has been decreased and you can control open and close by choke position or choke R. Here there is something called remote choke panel. This remote choke panel has here two gauges, one for the rail pipe gauge and the other for casing pressure. And we're gonna see the same remote choke panel in the simulator training and simulator exam. And we have here the remote choke R to open or close. Here is the regulator for speed, and here is a digital stroke counter. Okay, so you can read the number of strokes you already pumped to the system. The remote choke panel from below. And after that, after the fluid has been circulated from a choke and it is turned to the mud gas separator. Here, once we circulating out a kick, so the influx moves via the choke and goes to the mud gas separator here or bore buoy. Okay, so here there is baffles. Once the influx started to enter the mud gas separator, it hits the baffles. So gas started to moving upward due to its lower density and separated from the influx, and the mud returned back to down here to the mud seal, something called mud seal or liquid seal. Okay, we need always to keep the operating pressure high. If the operating pressure being low, this means that the liquid hydrostatic here, the liquid seal pressure, hydrostatic pressure has been decreased due to some gases or some condensate has entered the well. Okay, so we need to, if you look here, we need to start pumping a good mud with high density here to keep our operating pressure high, as if the operating pressure decreased, so gas may enter the liquid seal and being forced gas or forced influx to go to the shaker area, and with any simple agitation there is explosion or there is a fire. Okay, this is for mud gas separator. Here pressure build up, okay, or back pressure related to vent line ID. Once we have vent line ID very small, so it causes build up or back pressure. Once you have vent line height is high, the same thing will apply very friction, so will apply back pressure. So we need to higher vent line and low height. Maximum pressure with or operating pressure related to depth tube height and sea level. This one refers to mud sea level or liquid seal or mud tube. Okay, we need to always keep the pressure high here, not allowing gas to overcome the pressure, operating pressure, and enter the shaker area. After that, we having something called vacuum degasser. Once the fluid has been circulated from the mud gas separator, we're gonna use the vacuum degasser for any small droplets or for any mist of gases to be out of the stream or fluid stream. So here there is a question: what is the most Sorry, guys. Guys, are you online with me now?
Yeah, I'm here. I'm following you.
Okay, so you get reached vacuum degasser, or there
Not
is
exactly.
interruption from
Yeah, there was an
interruption from which point? Vacuum degasser or
Actually, if you could
before?
repeat it, will be better. No. You
Okay.
showed the schematics, and then there was an interruption.
Schematic. So you didn't hear anything about mud gas separator?
No, I heard them. I heard that actually.
Okay, so
73rd
you
slide.
heard about mud gas separator.
Yeah.
You heard about mud gas separator, right?
Yes.
Okay. So after mud gas separator, we gonna take the fluid stream to the vacuum degasser. Vacuum degasser here is used to remove any mist of gases out of the fluid stream. So here is a question: what is the most common use of vacuum degasser? The answer will be it is used to remove gas after the mud has been circulated across the shaker. After that, we're gonna talk about step-in valves or equipment used while tripping, okay, for more safety. These drill pipe safety valve and IPOP or inside blowout preventer. It is kept in open position on the rig floor for any flow during tripping. So, for example, while tripping out and there is a flow, we need to install the step-in valve in open position, then use this wrench to close. Okay, so we install the drill pipe safety valve in open position. Then for fluids not to up, as we didn't able to run the drill pipe safety valve in closed position, so we need to run it in open position to allow way for fluid. Then by this wrench, this one, we can close, okay, manually. And here it's called IPOB or inside blowout preventer. Okay, so it will be in open position also. We run it above the full opening safety valve, this one, drill pipe safety valve, okay, in open position. Then by this lock screw, we remove the lock screw, then this one is run in closed position into the well. Then we open here the drill pipe safety valve. There is something old called dart sub. This dart sub is old version. We run it in the drill string like the float valve, run it, then throw from the top of the drill pipe this valve to set in its place here in the drill string. But when you start to pump or anything like this, you will see a sudden increase in the pump pressure. This gives you indications that the valve didn't set in its place or there is any something caused plugging in the drill pipe. There is a question here, guys. Please check with me. This one. Could you share? Could you share, guys?
I think it's C. Yeah.
Yes. The answer is C. Okay. What about this?
I guess it's C again.
Yes. Okay, good. Now we have here something called the float valve. This float valve inside the drill pipe at the end of the drill pipe. Okay. We use it to prevent any backflow from the drill pipe. Here we're gonna talk about API wellhead connections. Here ring gaskets, then the flanges and the place for ring gaskets. We have many types of the wellhead connection, flange and clamp hub and studded like this. for types of flanges we have in our course, we have type called 6B. Its name is type 6B and type 6BX. For type 6B, we're gonna use ring gaskets from type R and RX, okay? And here for type 6BX, we're gonna use only type BX ring gaskets. Type ends with X like RX or BX, it's called self-energized ring gaskets, okay? So here for 6B, we're gonna use it, the flange 6B for low pressure rating from 2000 to 5000, and type 6BX we're gonna use for high pressure rating from 5000 to 20,000, okay? Okay, guys? But here, if you look here, for 6B, we need after making our test, there is a standoff, so need to retighten after test. If you look here for 6BX, no standoffs, okay? So it's better to use 6BX. Coming here, for installing the ring gaskets, this groove need to be clean and dry. Then we're gonna use this ring gaskets in its place to add more seal. Okay, ring gaskets only use one time. Even its visual inspection is good, but it is used only for one time. Coming here to further information about ring gaskets, API type PX pressure designed or energized ring gaskets called pressure energized PX and RX. Okay. Making of ring gaskets on ring OD. Here ring gaskets or ring joint gaskets type PX and RX joint gaskets should be used for flanged and hub type blowout preventer connection and cold self-energized type gaskets. Type R ring gasket not self-energized. RX here used with type 6B and 16P hubs, and type PX used with 6PX and 16PX hubs. So guys, now I think we're gonna finish our equipment part, our second part of our course, equipment. Okay, so any question related to this part, guys?
No, sir, it was a clear presentation, I guess. Thank you for your time.
Okay, guys. Okay, guys, you're welcome. So now let me make something, please.